Welcome back to another online video. Welcome back to our homeschool learning. This is Bunjit Widaya School's online video lesson featuring Math in Action. Today, you are going to learn another set of math concepts in English. Okay? Alright, let's begin. Showing you are the topics that we have covered in our previous videos. First, we had rounding and counting numbers to the nearest 10,000, 100,000, and 1 million, patterns of numbers, addition, subtraction, multiplication, and division of numbers, and factors of counting numbers. Later on, we are going to focus on the different factorization methods, the HCF and LCM. You will know more about this later. But for now, let's take time to review what we had on our previous video. It was said that factor is a number that is multiplied by another to give a product. Example, in the equation 7 times 8 equals 56, numbers 7 and 8 are our factors, while 56 is the product. Factors of counting numbers. Examples are the following: 1, 2, 3, and 6. These are examples of factors. 6 is a multiple of 1, 2, 3, and 6, and we call them 1, a factor of 6, 2, a factor of 6, 3, a factor of 6, and 6, a factor of 6. Let's just be very quick. How do we do factoring? How is it possible? Look at the example below. Mark has 12 apples. If he gives each of her friends 1 apple, he can give apples to 12 friends. But if he gives each of her friends 2 apples, he can give apples to 6 friends. If he gives each of her friends 3 apples, he can give apples to 4 friends. Now let's try to see figures. There are different ways to distribute the apples in division form, as I have mentioned last time. First, you can have this: 12 divided by 1 equals 12. Or, you can have 12 divided by 2 equals 6. 12 divided by 3 equals 4. Therefore, 1, 2, and 3 are factors of 12 because 12 is divisible by them. What are other numbers that can divide 12 without remainder? You can have 4, 6, and 12. Now, the complete factors of 12 is 1, 2, 3, 4, 6, and 12. Remember, remainder means the number that's being left during a long division method. If the numbers are arranged in one way, we are talking about factors here. If the numbers arranged in one way are numbers 2, 3, 5, and 7, they are called prime numbers. But if numbers are arranged in different ways, like 4, 6, 8, and 9, they are composite numbers. Prime numbers, composite numbers. Okay. What are prime factors? Look at the figures on the screen. You have an orange, a strawberry, an orange, a strawberry again, an orange, strawberry, and another orange. Let's put some numbers in each fruit. Let's begin with 10, 9, 3, 2, 5, 8, and 12. The factors of 10 are 1, 2, 5, and 10. Among the factors of 10, 2 and 5 are the prime numbers. We call 2 and 5 prime factors of 10. How about 12? Choose among these. What are the factors of 12? The factors of 12 are 1, 2, 3, 4, 6, and 12. Choose what are the prime numbers. Remember, prime numbers are 2, 3, 5, and 7. 2 and 3 are the prime numbers in the factors of 12. Therefore, we call 2 and 3 prime factors of 12. For this lesson, you can refer to your book. Alright, moving on. Let's talk about prime factorization. Again, prime factorization. Say it, please. Alright, good job. What about prime factorization? When we do prime factorization, I have here presented two methods. First is a factor tree. Say it again, please. Factor tree. Good job. This is an example of how a factor tree method looks like. From the main number, it branches out into even smaller numbers. This is factor tree. Say it again, please. Good job. Well done. And the second method is factoring by short division. Factoring by short division. Say it again. Alright, this is how a factoring by short division looks like. You will know later on how to do factor tree method and also factoring by short division. Let's have example 1. Supposing I let you factor the counting number below using factor tree method. Again, you are going to use the factor tree method to get the factors of the given number. And the given number is, okay, our given number is 24. Let's Branch and break 24. Okay, what are the numbers that when multiplied will give us the product of 24? Okay, very good. You can have actually different, but in this example you can see 4 times 6. Okay, 4 times 6 is equal to 24. Alright, now you can see that 4 and 6 may or can still be broken down into smaller factors. So for 4, you can have 2 times 2, right? Because 2 and 2 gives us the product of 4. 2 times 2 equals 4. And for 6, you can also have 2 times 3. Alright. Now, the numbers 2, 2, 2, and 3 are already smaller values. So, we can stop up to here. Therefore, the factor tree shows that 24 is equal to 2 times 2 times 2 times 3. You look at the last numbers in the tree. Again, the factor tree shows that 24 is equal to 2 times 2 times 2 times 3. Say it again, please. Alright, very good. Let's have another example. Example 2. Let's factor the counting number below using a factor tree method again. Let's factor. What number is this? It's number 12. Very good. Let's factor out 12. What are the numbers that can give us the product of 12? You can have 2 and 6. 2 times 6. 2 is not factorable already, so we can have 6. 6 can be 2 and 3, or 3 and 2. 2 can be written as 2 times 1, while 6 can be written as 3 times 2. We stop with these numbers. Therefore, the factor tree shows that 12 is equal to 2 times 1 times 2 times 3, or 2 times 2 times 3. Take away 1 and immediately write 2 times 2 times 3. By the way, this is 12. Excuse the typo error. Okay, that was factoring the number using factor tree method. This time, let's factor 120 below using short division. Alright? Let's use short division. Let's have 120. Instead of the line on top, we do it this way. So 120, let's begin dividing it by the smallest number, beginning with 2. So 120 divided by 2 equals? Very good. You have 60. Next, what is the number divisible by 60? We can still have 2. 60 divided by 2 equals 30. Great job. Can we still divide 30 by 2? Yes, of course. We can have 30 divided by 2. We get 15. Can we divide 15 with 2? No, we cannot. How about 3? Can we divide 15 by 3? Yes, we can. So, let's write 15 divided by 3 and we get 5. There is no number that can divide 5 already, so we stop until 5. Now, looking at this figure, we can say 120 is 2 times 160. And then 60 is 2 times 30. 30 is 3 times 15. 2 times 15. And 15 is 3 times 5. This is showing the factor tree method and this is showing division, right? Next, what are the ways to find the highest common factors? We have method 2. Let's use short division. Okay, now the question is, what are the factors of 24, 32, and 72 using short division? Again, this is short division. If you can remember how to use the short division, this would be easy for you. Now let's write the three numbers, 24, 32, and 72. Just like on the previous slide, we begin or start dividing the numbers with the smallest possible number, and that is 2. Now, divide it one by one, starting with 24. 24 is divided by 2, you get 12. 32 divided by 2 is 16. 72 divided by 2 is equal to 36. And then, move on. You can automatically use a higher number to divide all of the three numbers here. So instead of using 2 still, you can also use 4 because 4 is divisible with all of these three numbers. Now, you do 12 divided by 4 is 3, 16 divided by 4 is 4, and 36 divided by 4 is equal to 9. You can stop until 3, 4, and 9 because there are no any numbers that can divide the three of them. So make sure to look at the numbers to your right and your numbers or the numbers down below, which is 3, 4, and 9. Highest common factor of 24, 32, and 72 is 8. You multiply numbers 2 and 4. Again, the HCF of 24, 32, and 72 is 8. You got 8 when you multiplied 2 and 4. Understood? Okay. Next, what about common multiples? What are common multiples? Common multiples are 2 or more counting numbers that are divisible by those numbers. Can be divided with those numbers. Say for example, what are the multiples of 2 and 3? Basically, you are just likely to have skip counting in this focus. So you have 2. Your multiples would be 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth. And for 3, your multiples are 3, 6, 9, 12, 15, 18, 21, 24, so on and so forth. These are your, or this is the list of your multiples. To find the common multiples, same with common is the same. So you find the numbers the same in each number. Like 6 and 6, 12 and 12, 18 and 18. Thus, the common multiples of 2 and 3 are number 6, 12, and 18. So on and so forth. Okay, that's finding out the common multiples of numbers. This time, let's find the lowest common multiple. This time, it's lowest. It's not big, it's not high. It's lowest or smallest. Smallest common multiple. How do we do it? We do it still with the two methods, prime factorization and the short division. Let's do first prime factorization. We are asked to find the lowest common multiple of 6 and 8. So we have here 6 equals 2 times 3 and 8 equals 2 times 2 times 2. What you are going to do here is to bring down the numbers 2 and 2, 2 and 3. And you separate it with the multiplication symbol. And then you solve for it. 2 times 2 equals 4 times 2 equals 8 times 3 equals 24. So, the lowest common multiple or LCM of 6 and 8 is 24. That is through prime factorization. The lowest common multiple of 6 and 8 is 24. Another one. Let's use short division to find the lowest common multiple. What is the LCM of 8, 12, 10, and 15 using short division? What is the LCM of 8, 10, and 15 using short division? Write numbers 8, 10, and 15 and start dividing it with the smallest possible number. That is 2. Okay. 8 divided by 2 equals 4. 10 divided by 2 equals 5. 15 divided by 2. We can't have a whole number answer, so we bring down 15 as is. Next, numbers are already 4, 5, and 15. We cannot divide it with 2, but we can divide it with the factor of 5 and 15, that is 5. 4 and 5 cannot be divided with each other, so just bring down 4. And then 5 divided by 5 equals 1. 15 divided by 5 equals 3. Stop until there because there are no other numbers that can divide the 3. So to find the lowest common multiple for these numbers, you have to look the numbers at your left and the numbers down below. And then you multiply them. That gives us 2 times 5 times 4 times 1 times 3. A total of 120. Again, multiply the numbers at the sides and the numbers below. 2 times 5 times 4 times 1 times 3. That gives us 120. Therefore, the lowest common multiple or LCM of 8, 10, and 15 is 120. That is how you're going to get LCM using the short division. Okay, if you have not followed through the lesson, you can watch it again or refer to your books. I think that would be all for today. I thank you all for watching and listening. I hope to see you next time on our next online video. Goodbye everyone and keep safe always. Goodbye.